Good afternoon, everybody. This is Mr. Nold. I'm going to try to clear up any of the confusion we had yesterday with the multi-view orthographic drawing. Okay? So what you're looking at right here is what is the piece we were supposed to draw. So if I was there, you'd be looking at this physical piece. So from your PowerPoint, which you should have read in the language of sketching, is a multi-view orthographic drawing shows two or more two-dimensional views of a three-dimensional object. This is so builders, or even if you buy a new toy, it's so you get all the measurements and everything that comes next in the next PowerPoint, dimensions. Okay, so it's a great way to communicate, as the third point says, about between designers and manufacturers. So a great example, basically this is what you're going to be responsible for doing on your sheet of paper. Okay, so here you see the isometric view of this shape. Down in the lower left corner you see the front view of that shape, so that would match right here. Above that you see the top view, and to the right you see the right side view. Now I kept using the word adjacent, and I was hoping we would figure that out, but you see adjacent means these are lined up. So the bottom is lined up to the bottom, top is lined up to the top, sides are lined up to the sides, and the depth matches. Okay, so the depth here matches here. You'll see that when I do my drawing example. So here's another real life example of a dining chair with multiple views. Okay, so hence the name multiple view or multi-view. Alright, so here's what you would do to draw this piece for class. And this is what I want you guys to be able to try to hand in. So I have a sheet of paper that looks like this. And what I'm going to do is start out by hopefully you guys draw straighter lines in this. I think if I hold this, it'll snap it straight. Snap it straight. Oh, maybe not. Huh. Oh, yeah. So I did draw this out because I was practicing earlier. But what you would want to do is you want to basically cut your sheet into a quadrant. Okay, and we can label the top right will be our isometric. That's where we're going to draw the 3D shape. Top left will be the top of the shape. Bottom left will be the front. And then the bottom right side will be the right. I usually start with the right or the front view to do this. And on this sheet of paper, every square is equal to a 1/4 inch. So I'll make a little mark over here to let you know they're all a 1/4 inch, or you'd rate that as 0.25, correct? All right. So when you draw this out, draw the front side of that shape, and remember the shape we're using is this guy. So to kind of give you a better view, I drew this in, I'm so proud of this, by the way. This is what it looks like in a 3D view. So what we're trying to represent is the front view that looks like this. Remember, we can't see that hole there. And then when we draw the top view, we can't see the hole here. Well, once I'm over the top, I could just click on the top here. And then on the right side, you can't tell there's holes on there at all. Okay? So that's why we do this overall. I was proud of making that this morning, by the way. Anyway, so here we go. So I'm going to draw my front and do something like this. I guess I'm not. I can draw a better straight line than that. This is hard with a mouse, by the way. Hopefully it's easier on pencil and paper, but it really doesn't matter the sizes you choose, and it obviously is not to scale of the piece that we have in class. You just want to give yourself enough room to draw out the shape, and then big enough to make the circles. So this might be a little tougher for me, but if you made this bigger, if I made this a little bit bigger, I'd say the circle, I'd want it to be about 2 of these boxes wide or something like that. Okay, so here's my front view, and then I'm just going to draw my hidden to match that hole that goes through here. So that's why I have those dotted hidden lines. Up here in the top right corner, you're going to draw an isometric view of the shape, and this can look, I mean, my drawing is going to be absolutely beautiful. Of course it's not. So just try your best. It doesn't really matter what it looks like. This looks terrific so far, but I have a hole here and I have a hole here, so I just wanted to show an isometric view. Give that drawing your best effort. Not really worried about this. Okay, does that make sense? Anyway, over here, so when we talk about adjacent, when I draw the top view now, I have to line up. I want to make sure the one thing that people always make a mistake on when they do this is this line has to line up with this line. And then same thing over here, it has to be evenly as wide. And if you think about it, you really wouldn't be able to have an object that is wider when you look at it one view than when you look at it the other way. It doesn't make sense. This is an object line that's cut out here, so we're going to have to cut this piece in half with a straight line that you can see. It's an object line, so we can see that. So if you remember back to that PowerPoint talking about the alphabet of lines, if we can see it, it's an object line. Okay? Because my circle is 1 square deep, a circle that is looked at in two dimensions, or in an orthographic view, a cylinder becomes a rectangle, right? So I can just make my dotted lines there. And then this one's too wide, so I can actually draw this hole 2 squares wide. See how everything's lined up and adjacent, and even the hidden lines are lined up with this. Now for the right side, same type of deal. I'm going to draw that out like this. Ooh, there, I made it snap straight. And it's even from the bottom of the shape and the top of the shape, the same height. Now this is where some people get a little confused, but it's got to match the depth. Right here, 4 squares is what I'm using, or if at a 1/4 inch, I would say it's exactly 1 inch. More on that in dimensioning video coming up. But this is 4 squares deep. That matches this one here. Okay? So then I draw this shape out like this. Finish it this way, and you cannot see any holes at the right view, but you can see this object line where it's cut. So we have to represent hidden lines here and here, and then a vertical one. Oops, it would actually be exactly 2 squares wide for our hole that's here. Does that make sense? And so this is what a multi-view orthographic drawing would look like. If you have questions, and remember, I want you to give this an effort, and I want you to submit or email this to me so I know you can do that. So, review of the objectives for today. A multi-view orthographic drawing, which I just showed you. If I respond back to you, because I'll be at a golf meet, so I should be able to, I will say yes, go for your dimensions. Then you can look on Schoology. There's another PowerPoint on dimensions. But by the end of the period, I want everybody to attempt this drawing and email me what they attempted. Does that make sense? All right, people. Have a great weekend. Best of luck.